Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In last session I repaired this power supply, and approximately in last 5 or 6 power supplies same fault. Fuse burned out, MOV varistor damaged, capacitor here 2.2 microfarad 400 volts. This one. I found this capacitor damaged in each power supply, and I received comment from my viewer Paul, please show on a schematic where the bad capacitors are located. When we hold this power supply in this way, line neutral, line neutral. First component here, fuse. It is over current protection. Then there is MOV, varistor. It is non-linear, non-ohmic conductive component. When there is high voltage strike, either it is lightning, either it is any type of EMI or swelled line, when the voltage will increase at its threshold, it will start to conduct. If the line remains high for a long time, or continuous pulses are striking over voltage, high voltage pulses are striking, it becomes overheat. It damages. When it damages, it creates a short link here. When the current will increase, then 6.35 ampere, this fuse will burn out. Next circuit will be protected from high voltage or any type of strike. It will damage, it will melt. When it is melted, that time there is a short link. Fuse burned out, circuit disconnected. Then we have EMI filter, first capacitor, EMI dual line filter, second stage EMI, then this inductor, then both lines, this line is reaching here and this line is reaching here. Inductor entering here, AC line, AC line. From the same AC terminal, two tracks are moving towards these two diodes that are here. This line here, this line here. We can say like this. These two diodes, these are connected in this way. Here is positive, here is negative. These positive voltage are reaching here. Here is a capacitor, and this negative line is reaching at this point. For standby section, it receives voltage from here, but it shares ground line, common line from this bridge rectifier. These positive voltage are now applied to this transformer, that is this one, and its switch is here, IC. Whatsoever, I will draw a transistor. Suppose that it is IC. When this capacitor will damage, it will not hold charge. Normally when we think about capacitor, it will smooth the DC line. If here 220 volt, 220 multiply with 1.414, we can say 310 volt here, DC, that are smooth. If this capacitor is unavailable, that time 220 volt pulses will here, because it is full wave rectifier, but its amplitude will vary from 0.707 to the applied voltage 220 volt up to peak, from RMS to peak voltage. This will create ringing factor in this transformer because DC line is not smooth, and it will become a load on these diodes. The second condition, if it becomes short circuit or partially short circuit, that's called its capacitance will be converted into resistance. So it will become a parallel load to this DC line. We can say now it is working as a resistor. It will drop the voltage. When it will drop the voltage, that time these ICs, PWM controller, PFC controller, will receive VCC voltage from this transformer. When it will start to build the voltage, its input voltage are dropped, and it is the most common failure in the SMPSs when electrolyte capacitor at smoothing stage becomes damaged. It fluctuates. Its output voltage will not stable because this IC cannot adjust its duty cycle at any level because DC line is varying all the time. So this is the problem. When this MOV was short circuit, it was giving short link. In my last video when I connected jumper fuse here and I not removed MOV, its resistance normally it was giving 1.6 kilo ohms, but when we apply voltage, it is already in conduction state. When its chip temperature will increase, even I connected series lamp, it will start to burn. Its resistance will become very low. So that was the reason there was smoke from this MOV. When I removed, input resistance reached at 1.3 mega ohms. That is nominal resistance because we are testing these diodes in the bridge rectifier using ohm meters. So that is reason input resistance must be high in mega ohms. Above than 500 kilo ohms, 600 kilo ohms, that is acceptable depending on the circuit type. But normally this capacitor, it was making short link in this line. When this IC tries to start, but it cannot find a smooth DC line here, it receives this voltage. It will start, same time it will stop. Because this transformer cannot build proper magnetic field. This IC cannot adjust its duty cycle. Why? Because its input voltage level is fluctuating all the time. Transformer goes in ringing factor. This was the fault condition due to this capacitor. Fuse was damaged due to this safety. So we need to install safety component in each case. If you will not install MOV, if there is another strike when it is working, it will damage all the circuit, or maybe that strike will enter in the system where this power supply is installed. I hope you enjoyed this video. If it is good, if it is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.